Hi, we briefly review some important points in section 4. So at first, we studied the off payments. So off payments is the situation that the frequency of payments and frequency of interest are different. So we have two strategies. The first one, they use payment frequency for all. So this is usually the best way. And another way is the use interest earning frequency for all. So in this case, we need some trick to calculate the present value or accumulated value. Yeah, so first one, to use the payment frequency as the time unit. So this is basically the most important thing is to calculate the annual effective interest rate for this payment frequency. So if the annual interest rate is 3%, and the payment frequency is 5 years, what's the interest rate for 5 years? To calculate this J is important. Yeah, so you can review the details if you cannot remember the details. And another way to calculate present value or accumulated value of payments is to use the interest earning frequency. So suppose that the annual interest is given, but the payment is only once every 5 years. Then we can make the hypothetical, the cash flow. So this cash flow, the R dollars for 5 years. And we equate this annuity with this one payment of $1. You can see that this present value of the cash flow above time diagram is the R times A right angle 5. So if we equate this with this $1, that we can actually see this once every 5-year payment as the sequence of 30 payments. So in this way, that we can translate the less frequent payments into annual payments. So you can review in the detail, but finally, you have to get the ratio of the two annuity formula to calculate this kind of payments if we use the interest earning frequency as the time unit. Yeah, so another case is that the payment frequency is more frequent than interest earning frequency. So in this case, it's more complicated because, so we basically have to split the $1 into the several dollar payments. So we studied the formula A superscript M right angle N. So this is the formula to calculate the present value or accumulated value of the more frequent payments. So it gives the formula for 1 over M dollars for N years. So you can review the formula if you forgot this. So this has some complicated part such as I superscript M. So this is the annual rate, annual nominal rate, but it compounds the M times A. So these are off payments. So exam question is not too complicated. So just you can you have to remember the basics and concepts of this. Yeah, so exam doesn't ask the continuous questions, and not much the algebra such as when we cancel dots, double dots. Yeah, so just I want to focus on more important concepts. So increasing and decreasing annuity. So we think about, so this case. So this is the most important case for increasing and decreasing annuity. So we start with some payment, and the payment amount increases by the Q dollars per year. Then this is the N-year annuity. So this can be calculated by this formula. So present value is given by this and this plus this. So first step is identify P and Q. So P is the initial payment and Q is the increment. So if P and Q are given, then you can calculate the present value by this formula. So accumulated value are just the same thing. So if we want to calculate accumulated value, this is n years of interest. Yeah, so this accumulates n years of interest. So we have to multiply the 1 plus I, to the nth power, by PV to get AB. Yeah, some examples, you can review the videos. Decreasing annuity, just the same as the increasing annuity, just the Q is negative. Increment is negative. So this is very useful general formula. Perpetuity is basically the theory is the same. So perpetuity is actually easier than annuity because when we take the limit n goes to infinity, the sum terms disappears. So it's easier to see. Yeah, some more complicated case, such as the combination of the level annuity and increasing annuity. Yeah, another important formula is the geometric progression. So geometric progression, the basic case is this. So the payment amount is 1 plus k at time 1, 1 plus k square at time 2, I mean square of 1 plus k, and cube of 1 plus k at time 3 up to the nth power of 1 plus k at time n. And to say the conclusion first, actually this PV is calculated by just annuity formula, but we need some adjustment in interest rate. So this interest rate J is actually the I minus K. I is annual effective rate, and K is this growth rate, I minus K over 1 plus K. So actually, this is smaller than I, so I minus K, so subtract K, and also we divide by 1 plus K. So this is smaller than I. So that means that this PV is larger than A right angle NI. So of course the payment grows, so the PV should be larger, but basically we can only adjust this number J to get the present value. Yeah, so the concept is that basically for future cash flow, we have to discount to evaluate at present. But if it grows at the rate K annually, then we cancel the sum of that part. So we have to, the discount by interest rate I, but it grows in rate of K. So basically the K partially cancels I. So that's why we have the I minus K. Yeah, so you can check the formula. So basic concept is the K cancels the sum part of I. Yeah, several examples we covered. Yeah, even this kind of large growth rate, we can use the formula. So 1, 2, 4, 8, 16. If the amount doubles each year, still we can use the same formula with K is equal to 1. So 100% growth rate. And sometimes if K is really large, J can be negative, but still the formula works. So continuous ones are important, but it's less important in the exam because we have done this in some quizzes. Yeah, so we have some special case of annuity, the palindromic annuity. So this is some technical example. A 0% test may be useful as a test-taking skill, but this exam focuses on more fundamental things. So we skip this kind of technical things.